Honda offer a range of 5 different types of pumps covering a wide array of applications. Here we can see the range. The first one is the WX range, a small lightweight pump ideal for domestic and some industrial applications. This is the WB20, part of the WB range of pumps, ideal for construction use for shifting large volumes of water. This is the WH, high pressure pump, suitable for dust suppression, irrigation or local firefighting. The WT is our trash pump range, suitable for pumping again vast volumes of water in a construction environment, capable of pumping solids up to 31 millimeters in diameter. And finally, the 5th member of our range is the WMP, a poly pump, ideal for pumping chemicals, fertilizers or salt water. Now, all our pumps are centrifugal types, which basically uses centrifugal force to move water or other liquids. All pumps are self-priming, which will be explained later. What we'll do here is explain basically the differences between the pumps. They all incorporate 2 key components, the impeller and the volute, which determine the flow, pressure and the solid handling capabilities of the pump. We will see each pump has a very different impeller and volute, which ensure the Honda range meets a wide range of pumping requirements. Let's start by looking at this WB20 pump. We'll have a look at the key components in this pump, which are similar to all the other pumps, apart from maybe the size and the shape. We've got to remove the pump case to expose the inside of the pump. This is the pump casing, and inside here is a flapper valve, which is very important. When you first prime the pump by filling the case through here, the flapper valve prevents the water from leaving the case, which means you never have to prime the pump again, and this is why the pumps are called self-priming. This is the volute, which when removed exposes the impeller. The combination of the impeller and the volute set the pumping performance of the pump. Basically, all centrifugal pumps work on the same principle. Firstly, you must prime the pump. This fills the pump casing with water. If you did not prime the pump before starting, it simply would not work and cause serious damage to the mechanical seal. Without water, there is nothing within the pump to create the required partial vacuum. When the pump is primed and the engine started, a partial vacuum is created at the eye of the impeller. This allows atmospheric pressure to push water through the suction hose towards the vacuum or eye of the impeller. This is now rotating up to 3,600 RPM, which forces water away from the center of the impeller to the outer tips of the vanes where the pressure is highest. The velocity of the rotating vanes pressurizes the water, forcing it through the volute and out through the pump casing. For each of the pumps, I will mention 2 key performance figures: the flow, or maximum output capacity in litres per minute, and the total head in metres. The flow, of course, is easy to understand. This is simply the amount of water that can be pumped. The main variable here is the height that has to be pumped. Pump curves are available for all pumps, and these are easy to read. Simply look at the elevation you have to pump, and the curve will show what flow can be achieved. The total head can be a little confusing. Now, there are some common misunderstandings about what total head is. Very simply, it's the total vertical height the pump can lift and discharge. This is made up of suction lift, sometimes also called suction head, the distance from the water level to the center line of the water pump, and the discharge head, the distance from the center line of the water pump to the highest point it's pumping. For all Honda centrifugal pumps, the suction head is 8 meters. This is the maximum recommended height that water can be lifted inside a tube under normal conditions at sea level, which means the maximum lift. It is very different to total head, which adds suction lift and discharge height together. This is best demonstrated by looking at the WX10, which has been raised to 8 meters. You will see that the pump is lifting the water and still producing discharge flow. The discharge could be pumped another 28 metres high, giving a total head of 36 metres. Head refers to the lift only. It does not refer to the distance that can be pumped. Here you can see the WB and WMP lifting the water 6 metres and discharging 300 metres away. So that's the principle of how all Honda centrifugal pumps work, and an explanation of the terminology used when we talk of pump performance.